So another video, we are going to look at the my microphone now. Alright. Another video, we are going to look at reduction formula. Reduction formula. Now, in another reduction formula, we are going to look at the general view. If we have integral of 4 raised to the power n dx, okay, what if here is power 10, power 12, power 6? You see, we have solved that power 6 before, but that one was sine. We are going to look at such case, alright? So, once you have the formula, if the n is given to you, you just do the substitution, you go your way. If you also remember what we did in integration by parts, we will be looking at something like this and something like this. Alright? We'll be looking at the general form of all these that we are having here. So let's go straight to the point and move on. And that's for the log and the others. So that's all what we are going to do under the reduction formula. So here, hope you are following. So here what we do first is that we write that In is equal to cos n x dx. Now you know the reason why we have here I subscript small n. It's I subscript small n because what we have here is what? N. Very good. So the question says that obtain from a reduction formula to evaluate n is equal to what? 5. Very good. This can be I5. That's what it means. If In is equal to this, so we need to obtain before we evaluate. Alright? Sometimes people will be choosing formulas. They'll go and choose this formula without knowing how to derive it. And unfortunately, sometimes the question is just they obtain from a reduction formula to evaluate. How are you going to obtain it? So let's see how to go about it. Alright? Always, I keep saying, the understanding is the key concept. Oh. So now, we start. Alright, let's start. So here, we can rewrite this as n minus 1 cos ns dx. Having this is the same as this. From indices, you know this from indices. A raised to the power n times a raised to the power n. Let's say n minus 1. So with this, power 1. Alright. So with this, when you add n minus 1, when you add 1 to n minus 1, you are going to get what? N. So this is the same as that. Then we are going to use our idea in integration by parts to solve this question. So you know that in integration by parts, we set u and what? V. So we are going to set our u and v here. Very good. So here, we are going to let u to be equal to, now watch. If you let u, well, that you're going to differentiate to be this. It can work although, it can work alright, but to integrate this will be difficult for you to do that. That will not be better. So we let u to be equal to cos n minus 1 x. Then we differentiate. When we differentiate this is a chain rule because this is a power. So you multiply n of chain rule or general power rule. You multiply it by the whole of this. You multiply this by the whole of this. Then you differentiate the inside. So the inside is just going to be cos x. So when you differentiate, you get sine x dx. Very good. So that's what you're going to get for that. Then you set b. And the b is going to be the integral of cos the power n x dx. And when you integrate this, then you are going to get, I think there's a mistake somewhere. Oh, supposed to be power 1, alright? It's power 1 when you add this to this. I said it, but I mistakenly write n. I said when you add 1 to n minus 1, you get n. So that is that. So here is power 1. And this is going to give you sine x. So from integration by part, you know that in is equal to u times b minus the integral of b du. So by substitution, u is equal to this cos n minus 1x times b, which is sine x, minus the integral of b, which is sine x, times du. That is the whole of what is here. So we need a space. N minus 1 cos n minus 1 x sine x dx. Very good. So here by simplifying, we get cos n minus 1 x sine x minus the integral of. Now what's counting? What is the constant here? That is going to be n minus 1 integral of this to this. So let's rewrite this cos n minus 1x. Sine times sine, you get times sine square x dx. Very good. So the in is going to be equal to this. Now you can see that with this, we have to solve this one we have here by integration by what? Part. So we move on to solve that part. Not forgetting that here we can do a substitution. We can do a substitution of a Pythagorean identity to that place so that we are going to get everything there to be cos. So let's look at what I mean by saying that. So you repeat the whole of this, but the integral of. So here we get cos n minus 1x. Then this one we get 1 minus cos square x dx. So this multiply this. Then this multiply this. There is a mistake somewhere. Alright. Let's continue. So that is what we have there. So I would like to continue only that part. I would like to continue only this part. So let me repeat only that part here. Integral of cos n minus 1x. So now this will multiply 1. You get the same thing. How you can see that? Then this will multiply this. So don't forget, when this is multiplying this, the base is cos x. So the power n minus 2 plus n minus 1 plus 2. You're going to get n plus 1. Let me check if there is a mistake somewhere. I think so that there is a mistake somewhere. Yeah. The mistake is here. When we're doing the differentiation of this, we know it's a general power rule. So the power is like this. cos n minus 1. So this multiply the whole of this. What about you are going to get this? Then you subtract 1 from the power. So here will be minus 2. You subtract 1 from this, so you get minus 2. Then you differentiate the inside, then you get this. Sorry for the interaction. So now, that place supposed to be n minus 2. So here is minus 2, minus 2, minus 2. Very good. So I'm bringing only that part. This multiply this, you get cos n minus 2x minus this multiply this, so it will be n minus 2 plus 2, which is n. So we get cos x to the power n dx. Alright, so that is what we are going to get for that part. That's what we are going to get for that part. Because when this multiply this, as I said, you add to this, so this will a 2 comes over to the n. Now, having this, we can integrate each term dx minus the integral of cos the power n x dx. So we can integrate each term. So when you integrate each term, then you can now bring it to what we have here. So in general, we are going to get something like this. I need space to write this. I would like to put everything here. This part won't come. Okay, I'll get it here. So in all, In is going to be equal to the U times the V. The U times the V part, which is cos n minus 1x times the V is sin x minus, we are here, n minus 1, the integral of value. So let me draw this one here. Here, that is what we have here. The whole of this part is what we have here. So we are going to get cos n minus 2 n dx minus the integral of cos to the power nx dx. Now I can put this back. But remember that this is affecting the whole of the inside. Now watch. Okay, I'll bring that later. But let me bring it now. Why do we say that In is equal to this? Because the power here is n. That is why we bring In. So now watch. In the same cos and n. So now I substitute n. Looking at what we have here, it's the same as what we have here. So we can say that this one is In. And here is n minus 2. It's the same thing, just that here is n, but here is n minus 2. So then here we are going to represent it by I substitute n minus 2. So we get for n minus 1x times sin x minus n minus 1 I n minus 2. And again for, so we get n minus 1 in for this and this n minus 2. So in is equal to this. We are still proving or obtaining the reduction formula for integral of cos to the power n. So with this, we can send this to this side. Since they are like terms, in. So in minus n minus 1 I n, which is equal to cos n minus 1x times sin x minus n minus 1 I n minus 2. Very good. So here we get, you can see that here we can factor I n out. We get 1 minus n minus 1. Okay, so you can see clearly that here we are going to get 1 minus n plus 1. 1 minus n plus 1. Okay. Okay, let's continue. So what we have for that place is going to be when you factor in out, you are going to get here 1 minus this. And we know that here you are going to get in 1 minus n plus 1. Let's check that place well. I think it's supposed to be. Let me check that place well. Okay, so we get, yeah, this affects this affects this, plus. There is no mistake. Let's continue. So this place, we are going to get 2n minus 1. 2 minus n. Alright. Alright, I have seen where the mistake is coming from. It's not easy. And it's unfortunate that we have cleaned that part. So please, try and get it for me. When we were differentiating this, we have n minus 1, then we multiply by this, then we differentiate the inside. When you differentiate cos, you don't get sign, you get negative sign. So it's negative sine s dx. That is du. So go and change that place for me. So when you do the substitution, the negative here is going to affect the back here because you know that in is equal to u b minus integral of b du. Alright, so this du negation is going to affect this. So here is going to be plus. Here is going to be plus. So go and do that for me. So that place is going to be plus. So when you distribute, this here is plus. So when you distribute, when this affects this, here will be plus, but here will still remain minus. Here will still remain minus. Very good. So that is where the confusion is coming from. So that place will still remain to be minus. So when you send this one to this side, here is going to give you plus. Alright? So when you send this one here, this is going to give you plus. And factoring this out here, you get plus here. Alright? So you can see that here, you are going to get n. So that's what I was expecting. That's why I was somehow confused. That, wait a mistake. That's why always you have to know what you are doing. Alright. So forgive me for that mistake. And I'm sure some of you were aware of it. Okay. So here this is going to be equal to cos n minus 1s sine s minus n So now, okay, yeah, that's the right thing. So it just displays, okay, so here will be plus. Same this go to this side. So we are done. So here will be plus n minus 1, I n minus 2. Very good. So this, the inside is just going to be done with n. So we are going to get n I n is equal to cos n minus 1x sin x plus n minus 1 I n minus 2. Alright, so to get I n, divide both sides by n. And you get here to be 1 over n. You get here to be 1 over n. So simply, this is going to be the reduction formula for integral of cos of n. Please, it's not difficult. Just go back and play the video. It's just the, I think throughout of it, it's just the integration of the u, the differentiation of the u. That is where we had it to be the formula. Sorry for that also. Very good. So that's going to be the n. And the question says that evaluate n is equal to 5. So just do this. I5 is equal to cos power 4 because this minus this you get 4. Here you get 5. 5 here. X sin x plus 1 over 5. So here it's going to be 4 over 5. I 5 minus 2 is 3. So that's the what you're going to get for that. Don't forget that this one, this I3 is equal to the integral of sin raised to power 3. X. Alright. So you can continue with this by using the same formula. So you can continue with this by using the same formula. I would like you to continue with this. Just do the substitution to get I3. And come and do the substitution back. Let me help you with it. Let me help you with it some more, right? So now we know that I3 is equal to u. The I3 is going to be using the same formula. We are going to get 1 over 3 cos, so the power reduced to 2 s sin x plus 1 over 3. So here is going to be 2 over 3. I 3 minus 2 is 1. Very good. 3 minus 2 is 1. So now we get the whole of this to multiply 4 over 5, and that gives I5. But don't forget, I1 is also going to be equal to integral of sin s to the power 1 dx. And this we all know is negative cos x. Very good. So the I3 is exactly going to be 1 over 3 cos square x sin x plus 2 over 3 cos x, the negative. So here will be minus. So that's how we use the reduction formula. And in all, the I5, by substitution, the I5 is going to be equal to 1 over 5 cos to the power 4x sin x plus 4 over 5. Then this multiply I3. So you start writing from here. 1 over 3 cos square x sin x minus 2 over 3 cos x. So add plus to it after integration. So that's the end of solving such question. And with this, after getting the I5 completely, an interval can be given to you also. There are some cases that you can get an interval of 0, pi on 2. So when you get to this side, then you won't add the plus c since it's definite. Then you bring your upper bound and the lower bound or the limits to do the substitution. You know of this already. So that is how we do it. It's not difficult. Alright. Now, I would like you to try on this using the same question. Use the same question, but in this case, this is now sine x to the power n. It's the same idea, the same application. Apply it and use it to solve for this. This is in terms of what? Sine. Very good. In fact, the reduction formula for it is somehow similar. So that is how we obtain it, and that is how we use it to solve any question. In fact, if you let n to be 6, you get the same as the questions that we solved under the previous video where we were having sine raised to the power 6 and dx. You are going to get the same thing. Just that the reduction formula makes the work so simple and easy for you. But if you are not obtained and you are quoting the formula down to solve, it's just easy. So just easy. Thank you. Alright, the journey continues. Let's look at, in this case, we are going to look at the reduction formula for integral of a function in this form. Alright. So here, in the same way as how we do integration by parts, we know that our u is going to be x to the power n. So the u is going to be general power u n s n minus 1 dx. So the inside is s, so you get dx. Then the v is going to be everything left, which is e raised to power x dx, and that is e. So in is going to be equal to, and you know the reason why we are letting this to be equal to in, because we have our n there. Alright, so here we move on to u v minus integral of v du, and that is the formula. So in is equal to u is s to the power n, v is e raised to the power s, v is e raised to the power s du, and the du is n s n minus 1 dx. So in is equal to s to the power n s minus. The constant here is n, integral of e raised to the power s n minus 1 dx. Very good. Now here, we know that we are saying that this is in, because the s raised to the power n, because here is s raised to the power n. So that is why it subscript n. So now here is the same as this, but here is n minus 1. So here in is going to be equal to this in minus 1. So here we are going to get then I subscript n minus 1. So that is the same as what we have here. But here is what IN. So this is going to be the formula. So here you can be given that evaluate if n is equal to 6 or if n is equal to 3. So for n to be equal to 3, we get I3 to be equal to s to the power 3 e raised to power s. We get substitution 3i2. Then you go for I2. How you can see it? That's how you use the reduction formula. So when you go for I2, you still use the same what? Formula. This is the general formula. We still use the general formula. So we get s to the power 2 e raised to the power s minus 2i1. Knowing that I1 is equal to the integral of s to the power 1 e raised to the power s dx. Hope you can see how it's running through. So here we now integrate this. Okay, here is power 1. So I1 is equal to by substitution. The same formula we are using. Now we can see that the same formula. So when you see n, put 1 there. So s to the power 1 e raised to the power x minus 1 I 1 minus 1 I 0. So this part will go. So I1 is equal to s e raised to the power x. Alright, so yeah, 1 minus 1, that is 0. And yeah, that's what you are going to have for them. Very good. Okay, so let's use the same reduction formula. Let's use the same reduction formula to see what this I0 means. So getting the I0 here means that we know that I substitute is this. And we know that the I1 is the same as you do the substitution of n is equal to 1 here. So this is what we are going to get. So when you do the substitution back, in this, wherever you see n, put 1 there. So you are going to get this. So here, 1 here, 1 minus 1 here is going to be 0. Good. So by substitution, this substitute back to this. It means that I'm going to multiply the whole of this by a 2 here, and that's what we have here. Now, don't forget that the I2 will come here. We will bring that later. So let's go and look at what this I0 means. So wherever in the formula, wherever we see and we put 0 there. So x0 e raised to power x minus 0 I 0 minus 1. Wow! So even without thinking of this, what this means, the whole of this is 0. And this is 1. So we get e raised to power x. Therefore, I0 is equal to e raised to the power x. Please, I hope you are following well. That is how we use the reduction formula. I'm teaching you how to derive it and how to use it to solve. Alright? Very good. So now, if this is I0, then let's repeat I2. I subscript 2 is going to be x squared e raised to the power x minus 2. X power 1 e raised to the power x minus I0. And I0 is e raised to the power x. Woo! Wow, I love mathematics. So you see what we are getting now. So that is I2. So now we are bringing it here. I3 is going to be equal to x to the power 3 e raised to the power x minus 3 I2. So you bring the I2 x squared e raised to the power x minus 2x e raised to the power x. Is that 2x? Yeah. then negative negative positive 2 e power x. Alright, and that's the last one. So plus c. So finally, we are going to get 3 to 6 e raised to power s plus c. So finally, this is the answer we are going to get. Don't forget that we have used integration by parts to solve a question like this before. Alright? So all that is coming here is that if you are not restricted to derive or to obtain before you use it, you can code this formula down, start doing your substitution. If let's say this question is given to me, that means n is equal to 3. Then I'll do the substitution here. I come out with I2. I come and write my I2 that I know that I2 is integral of n squared e raised to power n dx. Then I go and obtain that. I get I1. I go and obtain I1. I get I0. I go and obtain I0. I get this. I go and obtain this. How big are we out there? So yes, man. So that is that for that. Let's look at the last one. One more thing. So this is how we use the reduction formula. I normally mistakenly call it reduction of order, but there is a reduction of order. What is also a subtopic under OD, that is ordinary differential equation, but this is not, it's not the same. This is reduction formula. Hope I can believe it. Please, I would like you to write all the reduction formulas down somewhere. Alright? It's going to help you a lot. It's going to help you a lot. Make sure you write it down. Also, know it off head. Know it off head. Very good. Now, let's move on. What if we have integral of log s to the power n dx? So here, we know that we have only two things here. We have 1 multiplying log of power n. When we set our u to be equal to 1, it's going to be difficult for us. And when we set our u to be equal to this, that's what is going to help us. So we set u to be equal to log s to the power n. Then the u will be equal to n multiplying log s, subtract 1 from it, integrate the inside. Sorry, differentiate the inside and you get 1 over x. Log is the same as mean s. Very good. So here you get n over s log s to the power n minus 1 dx. That is u. So we go for b. B is the integral of 1 dx, and that's going to give us x. So what is going to be in? That is ub minus the integral of b du. So u is what? U is log s to the power n multiplying b, which is x, integral of b, which is x, times du, n log s to the power n minus 1 we are writing u n over x log n minus 1 dx. This cancel this. We have log n times x minus the integral. The n is a constant. Log n minus 1 dx. Don't forget what is going to happen. N minus 1. So it's going to be in is equal to x log n minus n I is going to be subscript n minus 1 because that's exactly what is here, but here is n. So here is n minus 1. We have already established that. Very good. So this is going to be the general reduction formula for any question which is of this form. So when you are doing that, if n is equal to 2, what do you think is going to happen? That is, when here is 2 and you have to integrate this, just take this. That is general idea. So I2 is going to be s log s to the power 2 minus 2i. 2 minus 1 is what? 1. Then you go for I1. I would like to bring this back. Then you go for I1. So I1 is going to be the integral of log s to the power 1. Hope you can see that. dx. So just integrate this straight away and go. When you integrate this, you get 1 over x dx. Sorry, 1 over x. So we know that the 1 is 1 over x. So here is going to be multiplied by 1 over x plus c. So that's going to be the final answer for I2. In fact, you can set n to be equal to any number and start solving it. So that is how we do such case. In fact, we have done a lot. But I would like you to go and try on integral of n to the power n sin to the power n x dx. Go and get the reduction formula for this, knowing that you solve it as if you are doing integration by part. U is equal to x raised to the power n. V is equal to integral of sin n. But you can see how you're going to do. Very good. See you in our next video. Until then, bye-bye. But what is going to be our next video then? Don't forget that we are still under the techniques. We are still under the techniques of integration. And as I said, it's an interesting course. All these that we are doing is going to help you when you are doing OD. And in fact, before you go to OD, you have to remind yourself of all these things before you come to OD. So, in our next video, we are going to look at another technique, and that technique is called, where is this? Integration by partial fractions. Integration by partial fraction. We are going to look at the case where we are given an integral function to integrate, but we have to go in for partial fraction before we can be able to integrate it. So in fact, you don't need to forget your algebra, because if you don't know how to solve a partial fraction, you will be malnourished, or you are going to find it difficult in your algebra then. So please make sure you revise on your partial fraction and see me in that video. Until then, bye bye.